Hi, in today's video I would like to introduce a very nice proof. Here is the following circle with a radius r and origin O. Our goal, we are going to prove the area of this circle equal to pi is multiplied by r squared. Okay, I'm going to use Jacobian transformation in order to prove this area. Okay, so now let's talk through this one. Let's talk a little bit about this one. If you take a look at the center of this circle, if we're trying to make a small circle, okay, and then you try to make the second circle, and so on and so forth, you're making many circles, okay, until you get a last circle. Okay, so the way this circle is growing in over r, in terms of r. So the radius of this small circle is dr, the second circle is dr, the third one is dr, and all the way down until you get the whole r as a radius. Okay, if you take a look at these circles, each circle is making 2 pi to make a complete turn. Okay, for the dr, as you're going up from the small circle to the big circle, this dr is changing. Okay, this distance is changing. If you add dr plus dr plus dr and all the way down, the sum of these partial sums of dr is giving you the whole r. Okay, but for the small circle and big circle, if you take in the same origin O and different radius, because this is big circle, this is small circle, r1, r2. Okay, so the turn this small circle is taking in order to get a complete turn is 2 pi. Also for the big turn, the angle of this circle to make the complete turn is 2 pi as well. Whether you have small or big circle, you still have 2 pi as a turn, okay, for each one. But for the dr is making the big changing from the small circle to the big circle. So I'm going to express this one into the double integral. I have this double integral over region D. Let's call this region D as a circle. We have, by using the Jacobian transformation, I will have determined as a matrix of this component is multiplied by dr d theta. Okay, so in order to calculate G, I'm going to make the transformation Jacobian from the Cartesian coordinate into the polar coordinate. If you're looking for the bound for this one, for the r is going from 0 to r, because to make the complete circle, to make the circle is going from 0 to r. Okay, for the theta is going from 0 to pi. Okay, whatever. Now in order to calculate G, I'm going to calculate Jacobian G as a determinant. So I will get, let's set x equal to r cosine theta, y equal to r sine theta. Okay, so now for the G component as a matrix is giving us the partial of x, the partial differentiation, partial of x with respect to the r. For the second variable, I will get the partial of y with respect to r. For the second variable, I will get the partial of x with respect to the theta. For the fourth one, I will get partial of y with respect to the theta. Okay, if you calculate, this one is giving you cosine theta, this one is giving you sine theta, this one is giving you minus r sine theta, this one is giving you r cosine theta. So now I'm going to calculate this determinant. So this one is multiplied by this one minus this one is multiplied by this one. So I will have absolute value of g as a determinant of this one. I will get cosine is multiplied by r cosine theta, which is r cosine square theta, minus with this minus it become plus, r is multiplied by sine square theta. Okay, by taking r as a common factor, I will get cosine square theta plus sine square theta. This is its more known, this is equal to 1, so we'll have g equal to r. Okay, so I'm going to replace g with r here, so I will get the double integral, so the area of this circle from 0 to r as a bound. For the second integral, I will get the theta from 0 to pi, g equal to r is multiplied by dr d theta. Okay, so this one I'm going to calculate the first integral by taking this r outside of this integral because it's not depending on theta. So we'll get from 0 to r from 0 to pi d theta, the whole thing is dr. By calculating this integral is giving us 2 pi is multiplied by this integral from 0 to r dr. Okay, I'm going to rewrite this one here as a capital A, the capital A as the area of this circle equal to 2 pi is multiplied by this integral as r is goes from 0 to r. Let's put the bound as a capital R. Okay, to make the difference between the bound and the variable r. Okay, so we'll get from 0 to r dr. Okay, equal to 2 pi. By looking for the primitive of this one is given as half is multiplied by r square is evaluated from 0 to r. So the area of this circle, by cancelling number 2, I will get pi r square. Okay, so this one is a r square, is the same thing as r. Okay, so this is the area of this circle. Now I have done with this problem. Thank you for watching. I will see you in next video. Bye.